Welcome back to ECE 320A. We're working through a review for exam number 4, and we're on the last problem, problem number 10 of a previous exam from fall of 2015. And this is wanting us to sketch the Bode plot phase contribution of this transfer function. And I'm assuming that we've already written this in time constant form and we've identified all of the different pieces. And the first piece that we found was a constant, and that was a positive constant. I think it was a constant of 100. So in fact, this particular constant, since it's positive, gives us 0 degrees for all omega, and I've already sketched that. That contribution component is already on our diagram. Can you see it? It's at 0 degrees. We're finished. Let's now worry about the zeros. We have 1 0 at the origin, and that is always on, always contributing phase. And in fact, that's going to give us, since it's upstairs, it's in the numerator, it's going to be 90 degrees for all frequencies. And now I have to go up here and try to find 40% of the distance between, or however you want to think about it. But now I need to find 90 between 50 and 100. Let me just say that that's right here. And you could do this a little bit cleaner with a straight edge. But here is our 0 at the origin. And you might want to check your work at the end and saying, okay, where do we start? Well, we're going to start there. That's as low frequency as we can get as something at the origin. And at high frequencies, we better be finishing at the pole 0 excess, which is 3 minus 2, or 1 times minus 90. So we better be finishing at minus 90 beyond the highest frequency of interest. 1 decade above that, the highest frequency is this 100, so a decade beyond that is 1,000. So once we reach 1,000, which is right here, we now need to be at minus 90 degrees. We know where we're starting. We're starting at plus 90, and we're finishing at minus 90. And if you do nothing else, at least you've given me that information for some partial credit on the exam. Now let's walk through some of these that actually start and stop contributing slopes to our phase angle. And I like to walk through these from smallest frequency to highest frequency, and that's going to be independent of whether it's a pole or a 0. So I just start walking to higher and higher frequencies. In this case, my first break occurs at a pole. So let me say this is now my second sort of contribution in this phase curve, and that's a pole at omega equal to 0.01, or 10 to the minus 2. And this one now, I like to just identify 3 different frequencies and 3 different values of angle. It's 0 degrees, it's a pole, so it's going to be going down. It's 0 degrees a decade before the break, which is 10 to the minus 2 is the break, so a decade before that is 10 to the minus 3. It's now minus 45 degrees. It's only 1 pole at the break, and it's minus 90 degrees at and beyond a decade higher in frequency than the break, and so that's now at 10 to the minus 1. And well, I'll kind of squeeze in that curly bracket, but that's kind of ugly. Let's now sketch this. We're starting at 0 degrees, and then we go down to minus 90. We're at 45 here at the break, and then we're at minus 90, and so it's going to be right there. There is number 2. Number 3, as we go to higher and higher frequencies, what do I experience? Now I find that pole at 1, and that's now going to give me 3 different values at 3 different frequencies. It will be 0 degrees a decade before 1. It will be minus 45. Again, it's a pole at 1, and then it will be 90 degrees a decade beyond 1 or at 10. And now I can sketch that. It's going to be 0 at 10 to the minus 1. It'll be minus 45 at 1. So I go to 1 and I go to minus 45. And then I go to minus 90 right there. And here is my angle slope. It's 0 degrees and minus 90 degrees before and after that slope. Hopefully that's clear. Then what's my next one? My next one is another pole at 10, and so a decade before 10, or at 1, I'm at 0. At the break, I'm at minus 45, which is at 10, and then I'm at minus 90 degrees at 100. And let me sketch that. I'm 0 a decade before the break, which is at 1. So at 1, I'm at 0. Then I'm at minus 45 here. And then I'm at minus 90 at a decade beyond 10 or at 100. And this is now my fourth piece of the puzzle. And my last piece, component number 5, is due to the 0 at 100. And that now is going to be 0 degrees at a decade before that, or at 10. It will be, it's a 0, so it's going up in slope. It will be at plus 45 degrees at the break, which is 100, and it'll be at plus 90 degrees at a decade beyond that, which is at 1,000. So its contribution of slope will be spread over the 2-decade interval from 10 to 1,000. And so now I'm from 10 to 1,000. And in between, I'm at plus 45. So here is my fifth contribution. This was my first, that 0 at the origin. Now I need to put all of these pieces together. Just be slow about it. So now I'm starting at plus 90, then I go down 90 degrees total over 2 decades, so I'm coming down right to there. This number 2 contribution quits contributing, but number 3 kicks in at that point, and it's by itself in terms of slope until 4 kicks in, and then between 1 and 10 I have 2 poles active, so now I'm going down at not minus 45 but at minus 90 degrees. So I now need to go from minus 45 down minus 90 from that, or down to minus 135 by the time I reach 10. So now I'm sloping down here. Once I get that point, I now have this number 4 active and I have number 5 active in equal magnitude values of slope, but they're canceling each other out. So I'm actually flat until this number 4 contribution stops contributing slope. 5 continues contributing slope, so I should be going up at 45 degrees per decade, and then I will finish sloping and I'll just be flat at minus 90 degrees. So my phase curve now is what I've highlighted in yellow. I'm going down from 90 degrees to 0 over this 2-decade interval from 10 to the minus 3 to 10 to the minus 1. Then I continue sloping at that same 45 degrees per decade. So here's minus 45 degrees per decade until I reach 1, and then I'm doubling my slope. Now I'm going down at minus 90 degrees per decade between 10 and 100, the only two factors that are still contributing phase are that pole at 10 and that 0 at 100. And beyond 100, the only thing that's active is that 0 at omega equal to 100, and it quits sloping at 1,000. So now I'm flat all frequencies beyond 1,000, and this slope is plus 45 degrees per decade. And that red highlighted in yellow curve is my phase plot for this particular transfer function.